Hello everyone, welcome back to Chemistry Chronicles. This is part 1 of our physical chemistry lessons, and our topic for today is ideal gas. There are few laws of ideal gas. The first one is Boyle's law. This law tells us the relationship between pressure and volume when temperature and number of moles are constant. According to this law, pressure is inversely proportional to volume. That means if pressure increases, volume will decrease. As temperature remains constant, we will notice isotherm in our graph. Let's understand this better using a graph. In this way, we will have our pressure, and in this way, we will have our volume. As the pressure increases, we can see that the graph somewhat looks like this. That means the volume is decreasing, and each line in this case is called isotherm. We can understand this using another graph. We will draw the graph exactly like the previous one, except for the fact that here instead of volume we will write 1 over V. Then our graph will look something like this. Next up we have Charles' law. This law helps us understand the relationship between volume and temperature when pressure and number of moles are constant. According to Charles' law, if we keep pressure and number of moles constant, volume will be directly proportional to temperature. That means if volume increases, temperature will also increase. As our pressure is constant in this case, we will notice isobar in the graph. Let's understand this with the help of graph. Our volume goes this way and temperature goes this way. Now as the volume increases, temperature will also increase, and our graph will look something like this, and each line will be isobar. This law is very similar to the previous law, but this time it tells us the relationship between pressure and temperature when volume and number of moles are constant. According to this law, when volume and number of moles are constant, pressure is directly proportional to temperature. That means if pressure increases, temperature will also increase, and we will notice isochor in the graph. If we keep temperature this way and pressure this way, we will notice these lines that tell us with the increase of pressure, temperature also increases. Next, we have Avogadro's principle. With the help of this law, we understand the relationship between volume and number of moles when pressure and temperature are constant. It is very obvious that when there are more number of moles, the volume of the container will also grow larger. This one is the most important gas law, which is known as ideal gas law. This law states that PV is equal to ZnRT. But the compressibility factor Z is equal to 1 for ideal gas. Now let's have a look at the molar version of this one. If we divide both sides by the number of moles, then we get PVM equals RT. Vm represents molar volume. Let's have a look at this one. Dalton's partial pressure law is used to know the partial pressure or individual pressure of a gas in a container full of many gases. To find the partial pressure of an individual gas, we have to multiply the total pressure of the container by the mole fraction. The mole fraction, however, has to be greater or equal to 0. That means it cannot be negative and it cannot be more than 1. We have a law with the help of which we can find the partial volume of an individual gas. It's very similar to the Dalton's partial pressure law. To find the partial volume of an individual gas, we have to multiply the total volume by the mole fraction. The total volume is equal to the sum of the individual volumes of the gases. Lastly, we will learn how to calculate the mean molar weight of an ideal gas. The formula says that in order to find the mean molar weight, we have to multiply the mole fraction of each gas with its molar mass and then add all of them together. That was all for today. Thanks for watching. Subscribe for more such videos. See you in the next one.